The first thing I want to do is talk about what these graphs can tell us. So a position time graph tells us where we are each second. So where each second. And so if I were to look at this position time graph, let's say my 0 position right here. What if I were to make that like at a tree? Okay, so here's my tree. Wow, that looks terrible, doesn't it? Let me fix that. Okay. Oh, that's a much better tree. And I were to say, where was I at 8 seconds? Then what we would do is we would go to 8 seconds and up to the spot right here, which is at 7 meters. And so we would say at 8 seconds, I was 7 meters in front of the tree. Position is all about where you are. And so a positive position means that you are in front of whatever this 0 point is. In this case, I drew a tree. If you have a negative position, say I were to ask, where was I at 18 seconds? And so at 18 seconds, I'm here at -1 meters. That means I am behind the tree. And so negative positions mean behind whatever is the 0 point. Positive positions means you are in front of. So you can imagine here's this tree in the middle of some field somewhere, and we stretch out these meter tapes. And if we go in front of the tree, it's positive position. If we go behind the tree, it's negative position. The other thing that position time graphs can tell us is something about how quickly we were moving in these various locations. And so to figure out how quickly, that is all about the slope. So this section right here has a certain slope. The positive slope means we're moving forward because we are getting to larger positions relative to the tree. When it slopes up like this, it has a positive value, a positive slope. This section right here, I start at 7 meters and I stay at 7 meters for this much time. Therefore, I am stopped. If I'm stopped, my slope is 0. Now, what I'm going to do is go from 7 meters, go all the way back to the tree, and then start going behind the tree. This means I'm moving backwards. Backwards motion means that we will have a negative slope. This spot right here is again a horizontal line, so we are stopped again with 0. And then this one, we are again increasing in position. So we're going from behind the tree, back to the tree, and then going in front. So this means we are again moving forward with a positive slope. Slope here on a position time graph is the same as the velocity. Velocity is just how fast you're going in a certain direction. And so in this first segment, we are going forward, which is our direction, at a certain velocity. Well, the steeper the slope is, then the faster the value. And the shallower means the slower the value. This whole faster and slower is entirely about the number, not about if it's positive or negative. The positive and negative, there we go. The positive and negative are the directions. Nothing to do with the value itself. So let's see. What else can we do? All right, well, where would I be moving the fastest? Well, I'm moving the fastest wherever I have the steepest slope. The steepest slope is going to be at this backwards location. Where am I going the slowest? I don't consider 0 to be a speed. And so if you're stopped, you're stopped. Slow means you're still moving. And so between the other two that are left, this one, let's see, this is fastest. Between the other two, this one looks the shallowest. And so this is going to be the slowest. Again, it has nothing to do with if it's a positive or a negative. That's just what direction it's going. It's all about that slope. The next thing we can do is be a little bit more specific. Actually, let me put that back. We're still talking about the slope as velocity. What we've done so far is just concept, right? Well, we could actually find the specific speed in this direction. And so for that, what if I erase all of this and take a new color of red? All right, I'm going to look at this line right here. For this line, I know I am moving forward. And I can find the slope of this line, which will tell me the velocity. There are a couple of ways you can do this. One is you can actually just do, so slope is rise over run. And so if I were to do that on here, the rise would be, let's see, 1, 2, 3, 4, 5. So positive 5. And then the run, okay, even though it's only 2.5 of these little tick marks, you have to realize down here, this is 2, 4, 6, 8, 10 seconds. So to go, this is 2 seconds, this is 4 seconds, and so this is 5. And so we go up 5 meters and over 5 seconds to get a slope of positive 1 meter per second. Now, the other way you can do it is by doing the y2 minus y1. So equals y2 minus y1 over x2 minus x1. For this, we would need to find a couple of data points, okay? I would always pick ones that are actually on the intersection spots here, right? So this first one is at a time of 2 seconds at a position of 4 meters. And then this one is at a time of 4 seconds in a position of 6 meters. If we were to do that, y2 minus y1, 6 minus 4, and then we have x2 minus x1, 4 minus 2. That gives us 2 over 2, which is the same positive 1 meter per second. Now, what you would want to do is, of course, find the slopes for all of these different segments. And so, I'll tell you what if I now erase this? There we go. And give you what each of those are. All right, so from 0 to 5 seconds, we're going positive 1 meter per second. From 5 to 10 seconds, which is this section right here, we are stopped, and so it is 0 meters per second. From 10 to 15 seconds, that is our backwards motion, is negative 2 meters per second. 15 to 20 seconds, we are stopped again, 0. And then from 20 to 30 seconds, that is this one right here, is positive 0.5 meters per second. Now, you want to make sure that you can solve each one of those and find each of those values. If you need any help, of course, let me know.